Hello everyone, welcome back. This is Mr. Osemo Seppi, and this is a continuation of a differential application of problems. So before we begin, don't forget to like and subscribe. So the question reads: the function y is equal to x cubed plus ax squared minus 7x minus 1 has a stationary value where x is equal to 1. Find the value of a and the type and position of the stationary points. So let's begin by first finding the value of what? A. Alright. So now, to find the value of a and the type and position of the stationary point, we need to use the first and second derivative of the given function. So the first derivative will simply be y prime being equal to 3x squared plus 2ax minus what? 7. You can also just write the second derivative in advance, which would be 6x plus 2a. Okay, so now since the stationary point occurs at x is equal to 1, we can use this value of x to find the value of a. First, we have to set the first derivative that we found to 0. So let y prime equal to what? 0. So you have 3x squared plus 2ax minus 7 is equal to what? 0. After that, we can let x equal to 1, and you have 3 times 1 squared plus 2a times 1 minus 7 is equal to 0. Clean this up, you end up having 2a minus 4 being equal to 0. So 2a is equal to 4 divided by 2 divided by 2. A is equal to 2. That's the value of a. Now that we have the value of a, all we can do next is to find the type and position of the stationary point. Now we need to calculate the first and second derivative of the given function, which we have done that. But instead, in our case, we're going to put the value of a where it's supposed to sit. Therefore, this implies that y prime is going to be equal to 3x squared plus, so that will be 2 times 2, giving you 4x, then minus 7. Then y prime prime will be equal to 6x, and that will be plus 4. Okay, so once you do that, you need to find the stationary points of this particular function. Okay, so to find stationary points, we need to set the first derivative equal to 0. So I'll let y prime equal to 0, and I have 3x squared plus 4x minus 7. Once I do that, this is equal to 0, sorry. I can't really use the sum and product here, so we're going to use the quadratic formula. X is equal to minus b plus or minus root of b squared minus 4sc over 2a. So basically, in my case, let's fast forward a bit. So if we do some fast forward, x is equal to, if we say that if we use the quadratic, that would be x is equal to 1, and x being equal to, it would be minus 7 over 3. So basically, these will be the values of x at the stationary point, which would be the critical points to say in this case. So we can basically just test this positive coordinate or the negative point to see if we're going to determine the precise nature. Now, since we've been given that the stationary point is that x is equal to 1, we have to test at that particular point the second derivative. Then the second derivative, I will say 6, 1 plus 4 y prime prime is equal to 10. Being positive simply means it is what? A minimum one. So say minimum. Now, where exactly is this position? So the position is simply just the coordinates of the standing point, the stationary point, because it's one and the same thing. So the position, I would say, will be at x is equal to 1, and where the function of f is defined at 1. That will be your y. So if we define it at 1, basically we end up having, say 1, then we say plus 2 times 1 squared minus 7 minus 1, we get a minus 5. So this would be 1 comma minus 5. So this is the position. Alright, thanks for watching.